Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from autumn 2022. This paper is worth 120 marks in total, and this is the fifth video of 6. It will focus on questions 17 to 21, which account for 20 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 17. Tobias has a tank in the shape of a cuboid. It has length 40 centimetres, width 25 centimetres and depth 32 centimetres. He uses a jug with a capacity of 2 litres to fill the tank. The tank and the jug are shown below. So diagrams aren't drawn to scale, so we can't measure anything directly from them. We've got our dimensions of our tank, which is the shape of a cuboid, and then our jug that has a capacity of 2 litres. Tobias fills the jug to the top with water and pours it into the tank. He repeats this process until the tank is full. How many times does Tobias fill the jug? Okay, so we first of all need to find the volume of the tank, so we know how much water is going inside there. So to find the volume, we'll multiply 32 by 40 by 25. 32 by 40 by 25. Okay, so that's 32,000 centimetres cubed. This jug capacity is 2 litres, so 2 litres is equal to 2,000 millilitres, and 1 centimetre cubed is equal to 1 millilitre. So we can work with centimetres cubed and millilitres now because they're comparable, so that's important to note. So we want to see how many jugs will be needed to fill this tank. So we're going to divide the volume of the tank by the volume of the jug. So divided by 2,000. So that's 16. So there are going to be 16 jugs filled. So Tobias fills the jug 16 times. Question 18. Nathan and Lucy make and sell wooden items for gardens. Part A, Nathan makes and sells benches, tables and tool sheds. Last year, the profit he made from selling these items was in the following ratio. So benches to tables to tool sheds, 2 to 3 to 7 for the profit. Part 1, what fraction of his profit did Nathan make from selling benches and tables? So we're going to write each part of this ratio as a fraction to start off with. So this total number of parts in the ratio is 2 plus 3 plus 7, which is 12. We're interested in benches and tables. Okay, so benches was 2 out of 12 and tables was 3 out of 12. We want the fraction of his profit he made from selling benches and tables, so we've got 2 out of 12 plus 3 out of 12. If you're not comfortable with fractions, stick that in your calculator, making sure to arrow off your fraction. So that's 5 out of 12. But you could also recognise that the denominators are the same, so we can simply add the numerators. So the fraction of his profit that he made from selling benches and tables is 5/12. His total profit was £18,072. How much profit did Nathan make from the sale of the tool sheds? Okay, so we have benches, tables and tool sheds. 2 to 3 to 7. The total profit for all of these was 18,072. So I'm going to share 18,072 into this ratio. Now I already know the total number of parts is 12. So 18,072 divided by 12 tells me what one part is worth. So one part is worth 1,506. I'm interested in tool sheds, which is 7 parts. So 7 times 1,506 is £10,542 profit from the tool sheds. Part B, Lucy makes and sells planters. Each planter costs Lucy £32 to make, and each one she sells makes a profit of £80. What is Lucy's profit from the sale of one planter as a percentage of the cost to make the planter? So we're going to start by writing the profit as a fraction of the cost to make it. So she makes a profit of £80, but it only costs £32 to make that planter. So she's got £80 over £32. And if we multiply that by 100, 80 over 32 multiplied by 100, there's a 250% profit. Don't be thrown by the answer. We can make a 250% profit because she's made a lot more back than what she's sold. Question 19. The table gives a summary of the masses, grams, of 30 buzzards. So here's our table. Part A, Moen uses the midpoint of each group to calculate an estimate of the mean mass of these buzzards. He does this correctly. Calculate Moen's answer. So we're using the midpoint. So the midpoint is halfway between these two values in the range. If you can't spot it, add them together. So 600 plus 700. And then divide by 2. So that midpoint is 650, 750, 850, and then 950. So to estimate the mean, we're doing 650 multiplied by 8, 750 multiplied by 7, 850 multiplied by 4, and 950 multiplied by that frequency of 11. Okay, we're going to add these up, so we're going to total these values. Okay, so that's the total, well, the estimated total. We've got 30 buzzards in total, so to find the mean, we're going to divide by 30. So the mean mass of these buzzards is 810 grams. Part B, Dita decides to estimate the mean mass of these buzzards. She uses the values 600, 700, 800 and 900 rather than the midpoints. Explain why her method is unlikely to give a good estimate of the mean mass. Okay, so she's using the lowest point, so the lowest value that these data points could be. So she's using the lowest value, so her mean's likely to be too small. So it's going to be too small. Question 20. Debbie collects data about a group of 20 people. Her data is the total number of years for which they've owned a pet, so that's the horizontal axis, and the number of visits they've made to their doctor in the last year, so that's the vertical axis. The scatter graph shows her results and her attempt to draw a line of best fit for the data. So that straight line is her line of best fit. Part A, make a criticism of Debbie's line of best fit. So a line of best fit gives us an average that we can predict from, okay? So Debbie's line of best fit does follow the trend of the data. However, there are no points above the line. So it's not really giving us an average of those data points. We want it to be more in the middle. So we're going to say there are no points above the line. So we can't really use it to predict because it's following the trend of the data, but it's not giving us an average roughly in the middle. Part B. Debbie says, because there is a negative correlation, owning a pet for longer causes people to need to visit the doctor less often. Is Debbie correct? Yes or no? Explain how you decide. So we've got an explain how we decide. So we're going to need to think about this before we tick yes or no. Okay? So yes, there is a negative correlation. According to this graph, there's a negative correlation, but correlation doesn't imply causation, okay? So there could be another reason so owning a dog would mean you took more exercise, for example. But we can't say that. So we're going to say that there's no relationship between these two things. There's no relationship between owning a pet and visiting the doctor. Okay? It's just coincidence. Or owning a pet has nothing to do with going to the doctors. So correlation does not imply causation. There is no relationship between them. It is just coincidence. Question 21. Janet invests £5,000 in a savings account for 9 years. She makes no further payments into or out of her account in this time. Okay, so that £5,000 is all that goes in there. For the first 5 years, her investment earns 2% compound interest per year. After this, the interest rate decreases to 1.3% compound interest per year. How much is Janet's investment worth at the end of the 9 years? So we've got an investment of £5,000 and then we're going to multiply it. Now I want decimal multipliers for these percentage increases. Okay, so for the first 5 years, so the first 5, it's 2% compound interest. So she gets 100% plus 2%, which is 102%. If I divide that by 100, 102 divided by 100, that's a decimal multiplier of 1.02. So it's 1.02 for the first 5 years. So I'm going to put that to the power of 5. Okay, we're doing 9 years in total. So what about those other 4 years? Well, after this, for the next 4 years, we have an interest rate of 1.3%. So we've got 100% plus 1.3%, which is 101.3%. I want a decimal multiplier, so I'm going to divide that by 100. 101.3 divided by 100. So that's 1.013 as a decimal multiplier. So I'm going to multiply by 1.013, but that's for the next 4 years. So that's to the power of 4. And I'm going to stick this in my calculator. So 5,000 multiplied by 1.02 to the power of 5. Arrow out of your power, guys, so that you can then multiply by 1.013 to the power of 4. Just check I've put everything in right. We know that I make mistakes when I enter it in my calculator. Press equals. That's £5,813. I'm going to write the whole thing out to start off with, but we're working with money. So after those 9 years, the investment is worth £5,813 and 11 pence. Just check what they're asking for. How much is the investment worth at the end of the 9 years? There we go, £5,813 and 11 pence.